What's up, party people? Once again, it's Mr. Harris. And first thing I want you to do, if you're watching this live, do me a favor, like, share, and subscribe. This is a videos part 2 of a direct requested video from a client. And I want to say this before I get started. If you are watching this video and you know someone that's requesting a video for a specific topic, send me a message. You can type it in the comments, or you can just send a message to my email. The contact information is in the notes, and I'll get that video out to you. I think what I found is that I actually get into it when people send me different topics that they are requesting. It just frees up mental space for me, and then it kind of helps me get the topic ideas. So let's get into the content. We are going to, let me pull up the sheets for this. So we got this and this. All right, so now we're going to multiply radicals. And on this, I'm going to do my best. I know last video, but this space with this coming from the worksheet is kind of tough. So we have square root of 21 times square root of 7. Now there is a rule that says if I have the square root of A times the square root of B, then I can say the square root of A times B. Okay, so what that's saying is you can multiply the numbers under the radical. Please keep in mind that there's more than one way to do this. I typically, some videos I'll show multiple ways to do the same thing. But in this particular video, I'm going to just show it the way I've worked it out on paper. I also remember, well, let's just get into the examples. So I have the square root of 21 times the square root of 6, which is equal to the square root of, if we multiply 21 times 6, this is actually the square root of 126. Okay, so that's the square root of 21 times 6. Okay, and so square root of 126. Well, if we break 126 down, that equals 9 times 14. And please remember that list. If you create a list, and I'll show you in just a second, 9 times 14. Now, we know that 9 is a perfect square number. Let's do this in a different way. So 9 is a perfect square number. We can take the square root of 9 and put it out there. So then we get 3 times the square root of 14. And that's actually it, because 14 can't be broken down into a factor of perfect squares. So another thing that I like to show is, let's do this. I'll show this. So another thing I like to do is I like to show students that if you create a table of values, right? So if I have X and I have X squared, right? Excuse me. And I have 1, 2, 3, 4. This is a 13, okay? And if I take those numbers, okay, and you may not know these by heart, but at the same time, you can write these. It's good information to learn by heart. So if I take the number up top, another square, the perfect square numbers, okay? So these numbers on the bottom row are the numbers that I'm looking for to be factors in these radical expressions, okay? That's 121. Let me write that over here. 169. 225. I won't go any higher, but you can go higher if you like. So if you look at those, you basically want these numbers in this bottom row to be one of your factors when you break down what's on the radical. All right, so if I look at 18 again, remember, I can say the square root of 3 times 12. Okay, so that equals square root of 36. Now, 36 is a perfect square number, so this one simply just equals 6. So that one's a little simpler. When we go to 19, you can do this a couple ways. So what I did in this one was I have 24 and 42, right? I can multiply 24 times 22, but I also can say the square root of 4 times 6 times the square root of 7 times 6, okay? So now, since I have a 6 under both of those, what I can do is, just a second, let me see how I do this. 4 times 6 is 24. Let me look at my notes just a second. So I can say here, sometimes it's 42. So I actually notice that I have a perfect square here. And then since I have this 6 and this 6, right? Let's erase one of these 6s. Right? So this is where I kind of switched up the stuff. It's okay. So I have 4 times 6 times 6 times 7, right? So now notice the 4 is the perfect square, and then technically the 6s, since there's 2 of them, we can take out one of them, right? So we can take that to the front, right? So basically what you end up with is the square root of 4 is 2, and then times 6, and then you're left with, so take that out the top of the square root of 7. So you end up with 12 times the square root of 7. Now that was a little unorthodox method. I noticed I did these notes previous day. And so that would be your final answer. Let's do this. This is a reminder to myself to be mindful of when I switch up and show a new method when I'm working on videos like this. That was a drawn out method. Let's do 19. I'm sorry, no, 20. Let's do 20. So I can say square root of 6 times 7 times the square root of 6 times 3. Okay. So now what we can do is if I put them all together, I keep the 7 on the outside, and then I just simply say 6 squared, because there's a 6 here and a 6 here. Okay. And then times 3, right? So then since I have 6 squared, then I want to bring that 6 here. So I got 7 times 6 square root of 3. It ends up being 42 6. So 42 times. I'm sorry, actually, it's not right. Just create a 6. Stop hearing my audio went blank. Let's see. All right, hopefully this didn't mess up nothing. For some reason my audio switched over. So let me stop sharing for a second. Okay, y'all should be able to hear me good. All right, so let's go. All right. I had to make sure we got this right. So let's go on to 21 then. So 21, I have square root of 3 times the square root of times -4 square root of 5. So I'm gonna keep the -4. Okay, and then I'm gonna say the square root of 3 times 5. All right. And that one, there's nothing really to do with it because 3 nor 5 is a perfect square number. So we can just say -4 times the square root of 15. All right, boom. Here, 22. I have negative, so I can multiply these two together, or I can simply just break this first one down because I know 4 times 3, and then times square root of 7 times 3. I knew 7 times 3 because I had a 3 in the first one. So now we look at the perfect square number from the first radical. So boom. Well, actually, let's write it all again. So negative square root of 4 times 3 squared times 7. Now, we know 4 is the same thing as 2 squared, okay? So boom, we're going to take that out of there, and then we're going to take this 3 out of there as well. So we end up with, I'm going to write it down here. Square root of 4 is 2, and then 3 squared, so times 3, and then we're left with square root of 7. So that equals 6 times the square root of 7. Now, I know this may look kind of crazy because it seems like it's like, wait, how did you switch up? Okay, and I got to keep this negative. So I got this negative out here. So that definitely is negative 6 times square root of 7. All right. Let's do 23. I'm going to do 23 in the middle here, so I can use some space. So I got the square root of, so we're doing this particular problem. So I have square root of, let's see, 5 times 7 is 35, and then times negative 2, the square root of 7 times 3. All right, so now I'm going to put it under one radical, so negative 2 square root, I'm going to say 5 times 7 squared, because I have this 7 and this 7, and then times 3. All right, so then now, since I got that, I'm going to take this 7 and it's going to go out front. So I have negative 2 times 7, and then square root of 5 times 3. So I'll get negative 14 square root of 15. Okay, so as y'all can see, this is a different method to make less work, because some of these numbers, they're so large when you multiply them, you get some gigantic numbers. Okay. So then 24. So 24. Whoa, what's my pen right? All right, so I have 7. We're doing 7 square root of, let's do 5 times 2. Let's break that down. Times square root of 4 times 2, because 4 times 2 is 8. Now we're going to bring this together. We're going to say 7 square root. There's only one 5. There's 2 2s, so 2 squared, and then times 4, which we know 4 is also 2 squared. Okay, so we're going to circle this one and this one. Now we got to take the square root of this 4, which is 2, and then we just take that 2 right there. So we end up with 7 times 2 times 2, square root of 5. 7 times 2 is 14. 14 times 2 is 28. So we get 28 times the square root of 5. All right, so that's all multiplying radicals. Now let's go to the division. Division is similar. Now there is a rule that says that if I have the square root, there is a rule that says if I have the square root of A over the square root of B, then I can simplify it to be the square root of A over B. We could do that, but the thing is we're not going to necessarily use that one in this case. We're going to do what's called rationalizing. That's not spelled right. Rationalize the denominator. Okay, so we're going to rationalize the denominator. And I'm going to show you what that means. All it means is just we're going to multiply by the radical here. Okay, so here in number 25, we do all the work over here. I have the square root of 2 times the square root of 3. So there's a rule that says we cannot have a radical in the denominator. Okay, so that's why we rationalize the denominator. So what we have to do is we have to multiply this numerator and this denominator by whatever that radical is in the denominator. Okay, so now here I have square root of 2 times the square root of 3 equals the square root of 6. And then the square root of 3 times the square root of 3 is just 3. Okay, well, you might say, well, how do you know that? So the square root of 3 times 3 is 3 squared, right? Well, this and this are opposites of each other. Okay, so this is your final answer for number 25. All right, we're going to do the same thing in 26. Okay, so 26, we have 4 square root of 2 over square root of 3. Okay, so now we're going to multiply the numerator and the denominator by the square root of 3. All right, and that's going to give us in the numerator 4 times the square root of 6, because 2 times 3 is 6, and then over 3. All right, and that's it. You can't simplify this fraction, so that's it. That's the answer to 26. All right, let's erase. Uh, 27. 27 says square root of 4 over 5 times the square root of 6. So we're going to do the same thing, but we have to multiply by 5 times the square root of 6. So we got to multiply by that whole denominator, 5 times the square root of 6. Now, when I multiply these on the bottom, this is 5 times 5. So this times this, so that's 25. And then square root of 6 times the square root of 6 is 6. Okay, so on the top, I have 5. On the outside, square root of 4 times the square root of 6 is the square root of 24. Okay, now for the square root of 24, I could say that is 4 times 6. So technically, I have 5 times the square root of 4 times 6 over 25 times 6 is 150. Okay, so now, but remember, I got to actually take this 4, take the square root of that and multiply it by this. So I have 5 times 2 square root of 6 over 150. All right, so I get 10 square root of 6 over 150. And so 10 can be reduced by 10, so I'm left with the square root of 6. So if I just basically take this 10 divided by 10 and this 150 divided by 10, I get 15. So I get the square root of 6 over 15. All right. So that's the answer to number 27. Okay, so 27. Boom. All right, let's go 28. Okay, I have the square root of 3 over the square root of 2. This one's rather simple. So I multiply by the square root of 2. And then I get square root of 6 over square root of 2 times square root of 2 is just 2. So that's that. All right. See race again. Yeah. See race again. All right. We are on number 29. So we got 4 more. 2 square root of 6 over square root of 15. All right, so you're going to multiply by the square root of 15 here. Multiply by the square root of 15 here. All right, so that gives me 2 in the numerator. 6 times 15 is square root of 90. over 15. Now, I'm going to break down that square root of 90. So this is the square root of 9 times 10 over 15. Now, 9 is a perfect square number, so we're going to take the square root of that and multiply it by that 2. So we have 2 times 3. The 3 comes from the square root of 9. Keep the 10 under the radical over 15. So I got 6 square root of 10 over 15. Now, we can reduce that 6 and that 15 because they're both, it's like a fraction. So 6 over 15 can be both, 6 and 15 are both divisible by 3, right? So 6 divided by 3 is 2. Keep the square root of 10. 15 divided by 3 is 5. So boom. All right, and that's 29. 30. Let's go yellow. All right, so 30, I have 5 times the square root of 8 over 4 times the square root of 20. I'm going to multiply both of these by 4 square root of 20 and 4 square root of 20 here. So now in the denominator, 4 times 4 here is 16, and then times 20. In the numerator, 5 times 4 is 20. And then 8 times 20 is 160, so square root of 160. All right, now we got to break that down. All right, so in the numerator, I keep my 20, square root of 16 times 10. And in the denominator, 16 times 2 is times 20 is 320. So then now, let's break this down. Let's say 20 times the square root. Now, this is a perfect square number. So let's erase this. So we can say 20 times 4 square root of 10 over 320. All right, so that gives us 20 times 4 is 80 over 320, which we can reduce that times the square root of 10, okay? So 80 over 320. So now we can divide both of those by 80. 80 divided by 80 is 1, and 320 divided by 80 is 4. So we end up with square root of 10 over 4. All right, 2 more. And that yellow's kind of bright. Let's see, 31. I have 2 square root of 4 over 5 square root of 3. We're going to multiply both of those by 5 square root of 3 because that's in the denominator. And so here in the numerator, I have the 2 times the 5, which is 10. 4 times the 3, because they're both under the radical, so that's 12. In the bottom, 5 times the 5, which is 25. And then times 3. Okay. Why we get the 3 here? Because square root of 3 times square root of 3 is just 3. So I have 10. I have 4 times 3, because I could break that 12 down into a product of a perfect square number, then over 75. All right, so now I got to take the square root of that 4 under the radical and multiply it out there. So I have 10 times 2 square root of 3 over 75, which equals 20 square root of 3 over 75. Now, the 20 and the 75 are both divisible by 5. Okay, so that 20 divided by 5 is 4. Keep the square root of 3. 75 divided by 5 is 15. So there's our final answer to number 31. And last but certainly not least, we got 32. We have the square root of 2 over 6 times the square root of 3. We're going to rationalize this. We're going to multiply by 6 square root of 3 in the numerator and the denominator. Okay. So here, we keep the 6 on the outside, and then square root of 2 times the square root of 6. In the bottom, 6 times 6 is 36, and square root of 3 times square root of 3 is just 3. So we have 6 square root of 6 over 36 times 3 is 108. All right, and now 6 and 108 are both divisible by 6, right? So this 6 in the numerator divided by 6 is 1, so we're just left with square root of 6. And then 108 divided by 6 is 18. So boom. That's your final answer, square root of 6 over 18. All right. Now, I know this is a lot. But remember, that's the reason why you got videos to watch. Pause it, rewind it, get some understandings, type questions in the comments, do what you need to do. And if you have any questions, by all means, post it in the comments. Send me, I'll get those notifications directly to my account, and I do respond to all the comments. So bring them on. Like, share, and subscribe. Hopefully this helps. And remember, I got